All right, we're live.
Okay, so welcome, greetings everyone, and welcome to the online telescope at Slooh. This is the How to Use Quest in the Classroom Professional Development webinar. I'll be your host, Director of Curriculum, Dr. John Boisvert, and today I will introduce you to learning activities that we have on Slooh's online telescope. Now, I hope we can all see my screen right now. Here's a brief agenda for tonight. So we're going to learn about quests and missions. Then we'll dive into the basic structure of a quest with one of our starter quests, Nifty Nebulae. And then we'll check out a few other quests to see how data collection and some of the various assessment tools operate. From there, we'll cover some ways that you can use quests in the classroom. And I'll point you to a few of our past PD webinars to check out that cover even more ways to utilize quests in the classroom. Now, I will show you a preview of some of our upcoming Quest features and learning progressions as well. There will be some time for Q&A at the end, so have your questions ready. Now from here, I'm going to head on to the dashboard. So what is a quest? Quests are interactive lessons that challenge your students to use the online telescope to collect and analyze data to form their own conclusions. Quests teach students how to explore space in a self-directed manner while completing learning activities that challenge them. There are over 50 quests that span STEAM core subjects and more. Each of these badges is a quest for students to embark on. So there are over 50 quests that span STEAM core subjects and more. Each of these is a badge that students can embark on and learn about the universe using the online telescope. A remarkable aspect of astronomy is that it touches on many subjects and topics. Therefore, quests inspire the learning of scientific reasoning in an exciting and engaging way. A Slooh quest culminates in creating a poster-sized infographic that showcases the students' images captured themselves with Slooh's online telescope. That's right, your students make these posters during the quest. And in some cases, their infographic incorporates responses to questions in the quest as well. These personalized infographics generate a spirit of accomplishment for the student while providing an easy tool to recall the content they learned while on the quest. Since students use their own captured images, every student poster is unique. No two posters are alike. This flexibility allows students to explore their artistic expression and create something that speaks to them and for them. Now, throughout the show, we're going to look at some nebulae through the, we were going to look at some nebulae through the telescope so that we can build our own nifty nebulae poster together. And we'll briefly touch on the different nebulae that we're seeing. However, unfortunately, it's cloudy in the Canary Islands and in Chile tonight. So I do have some backup shots that I'll be able to share with us tonight, and we'll still be able to build this poster together. Now, quests are a great way for students of all levels to stay engaged in the platform as they give students structure and provide goals for learning and capturing images for their collection. Students follow in the footsteps of professional astronomers, from learning about their captured objects in Slooh's online telescopes to planning and executing authentic observational astronomy missions by considering factors that may affect their outcome, such as weather, object altitude, moon's location, and more. We will cover multiple ways of scheduling missions tonight. Students complete reading exercises, data collection, planning, and execution, data and image analysis, quantitative and qualitative questions, and more as they progress through the quest self-guided activities. Now, quests are a significant part of our gamification at Slooh. Students collect a heap of gravity points by completing quests, which they need to progress through the 9 levels on Slooh. These levels honor the contributions of famous observational astronomers worldwide, from the classical era to the modern day. The first level is Ptolemy, who believed that the sun orbited the Earth, and ends with Hubble, who proved that the universe is expanding. Now, I'm currently at the Galileo level. Now, students are awarded badges to their profiles as well when they complete quests. These badges foster a feeling of accomplishment that grows with each badge earned. Now, let's talk about missions. This is how you and your students control the online telescope. Students control the online telescope by scheduling missions. So if we scroll down on the page a little bit, we can see that there's going to be a portion on the dashboard called missions. So this is the easiest way to go on a mission. It's by using the Slooh 1000, the 1000 most spectacular objects in the night sky. Now, a Slooh mission is a fixed time to look at a particular object with a specific telescope. So let's see the easiest way to schedule a mission with the Slooh 1000. So let's choose a category. So first, let's maybe choose emission nebulae. Since we're going to be building the nifty nebulae poster together, let's go ahead and see what it looks like to go on a mission. So what's happening is right now, the platform is looking at all of the emission nebulae in the universe, and it's figuring out which telescopes can see them. And so we have this step 2, choose object. And here, these are all of the emission nebulae that are available for us to capture with Slooh's telescopes. So objects that have the dark text are objects that we can see, and objects that are grayed out, we're not able to capture tonight. So maybe let's do the Eagle Nebula. So when I hit on Eagle Nebula and hit preview mission, the Slooh platform will provide me with a mission to go on. So a Slooh mission is a scheduled time to look at a particular object with a specific telescope. Cool. So if I want to schedule this mission, I can just hit schedule mission, and then boom. Once this time rolls around, Slooh's online telescope will slooh to your object and capture an image. And not only that, it will process it in real time using Slooh's patented technology and deliver it to the student's personal collection after the mission completes. Now, students do not have to be on the platform when their mission occurs to obtain their image captures, although they are encouraged to keep looking through the online telescopes as their image is automatically processed in real time. It's really neat to watch images go from being in black and white to color, which is exactly what you're going to see through the online telescopes. So I wish that they were on right now, because I was going to show you how to snap an image from the telescopes, the live telescopes as well, because that's another thing that students can do. Students can hang out on the telescopes all night long or until their bedtimes and snap missions. There are a few other ways to schedule missions on the telescopes though, and I do want to show you some of these to make sure that you understand some of the differences. So we originally saw the Slooh 1000 method of scheduling missions, but here let's use what are called the object guides. And this is going to be important, especially when working on quests, and you'll see why. So when you click on this magnifying glass, this allows you to look through all of the different guides that we have on Slooh. There's guides for the different observatories and for the different telescopes, but also every object has its own guide. So we looked at the Eagle Nebula before, or scheduled a mission to the Eagle Nebula. Let's go ahead and check out its guide. So I type in Eagle, hit find, here's Eagle Nebula. Now the guide pages, they give a lot of information about the object, some astrometric information, some visibility information, but the point of me showing you this is actually to show you this mission tab. When you click on this mission tab, this gives you a little bit more flexibility with scheduling than the previous way that I showed you. So here we can actually choose a day up to a week in advance to schedule a mission. And then we can choose observatory if we want to go to the Canary Islands or Chile. Now, the Canary Islands Observatory is going to be the first that's on the page. And if we continue scrolling, we'll see information for the Chile Observatory. So the Canary Islands Observatory is on the top, followed by the Chile Observatory. And these, as you can see, are missions from the Canary Observatory that are being provided to us. And we get to choose which one we want to schedule our mission for. Now, this first one is actually the one that we scheduled using the Slooh 1000. And wow, that's awesome. There's actually a few people who are already going on this mission with me, which is awesome. But here's where you can see you get more flexibility. We get a little bit of a weather forecast for these missions. And we can see, well, light clouds, you know, we may get a good image, we may not. There's also the object's altitude, which is how many degrees above the horizon is this object. Typically, you want to capture images when this number is a large value, and it also gives you information about the moon. Now, the moon is important because it's very bright. When the moon is in the sky and it has a considerable phase, it sort of affects image quality a little bit. So all of these things are necessary for students to learn about and understand to capture great images to complete their quests. So if I scroll down to Chile, now it looks like we got light clouds to partly cloudy skies as well. Well, this is where some of the magic can happen. What about tomorrow? So if we scroll to tomorrow, looks like we still got some clouds in Canary. But if we go down to Chile, it looks like we have clear skies. So this is exactly where we would want to go. Let's see, 21 degrees, 31 degrees, 42 degrees. This one is totally the one that I want to schedule to get a capture of the Eagle Nebula. Now, you and your students can see the missions that they've scheduled right on their dashboard. So when you go back to the Slooh dashboard, all we need to do here, I got one right here. All I need to do is scroll down a bit. So here's the missions tab. If I scroll down a little bit more, here's the mission schedule and advanced mission schedule. So these are the two missions that we scheduled together. And these are actually the number of missions that I scheduled to facilitate tonight's show. Fortunately, it's going to be cloudy tonight. So one more thing I want to talk about in terms of missions. And for this, I'm going to navigate to the one of the telescope pages, particularly Canary 2. You could do this with all of them, but I just chose Canary 2. Why not? And in the telescope pages, you will find the queue. And the queue is basically the schedule that the telescope is going to follow tonight for capturing objects. And what's really neat about this is if I scroll down a little bit, start to see that certain missions have these three dots. And if I click on that, it says join this mission. So if I click this again, this would allow me to join that mission. So what you could do as an educator is you could set up missions and ask your students to join those missions. That way you all have the same images for progressing through the quests, if that's how you would like to do that. All right. So I think that's enough about missions. Let's now talk about quests. And I want to go through the Nifty Nebula quest together. And you can access that quest by clicking on the quest badge down here where it says Nifty Nebula. Nifty Nebula is one of the starter quests. It's in the lower left-hand corner. When I click on this, you'll notice some important information about the quest is displayed on the quest card. It indicates the average length of time it takes to complete the quest, which assumes one successful mission a day, how many gravity points students earn, when the quest is available, which is incredibly important, the difficulty level, and also the quest description. If you haven't started the quest, there'll be a button that reads Start Quest next to this View Quest button. But for me, it says View Quest because, well, I've already started the quest. So when I hit View Quest, it'll take me to the quest overview page, which contains a table of contents. Now, before we dive too far into the quest, I want to show you another way to access the quests that we have at Slooh. So sometimes you may be looking for a quest of a particular name, and it could be challenging to find it on the quest map. So you can access quests by the menu in the top left corner of the page. So the menu are these three parallel lines here. And you click on that, you can see we have quests. So when I click on quests, it brings me to the quest hub. Now this is all of the quests that we have at Slooh in alphabetical order. We can also filter out these quests by type. So here's all of the starter quests, for example. And then it's a good idea for you to know that there's also this My Quest tab as well. And My Quest tab contains all of the quests that you or your students, depending on which account you're on right now, the quests that they're working on and the quests that they've completed. Okay, awesome. So when we access the quest from this quest page here, it takes you directly to the quest overview page. So you miss that quest card when navigating to the quest from the quest map. However, the information that you miss on the quest card is readily available in the quest overview. Additionally, there's aligned OpenStax Astronomy college chapters and NGSS curricular codes as well. Awesome. Let's dive in. So quests are a series of steps, and each step has multiple panels. Now, the typical quests begin with an introduction to the activity and often includes one question, at least one question. This reminds students that they need to read through the material. Now, notice that there's this check mark here. This check mark indicates that this step is correct. And there's also a little correct here as well. Now, if I were to choose an incorrect answer, you'll notice that this check mark goes away. Not only that, every step has one of these status icons as well. So right now, step 1 is not completed. So let me change that. Let's go back down. What does the word nebula mean? Well, the word nebula means cloud. So when we click on cloud, it says correct. The status changes back to this dark background check. And if I scroll all the way up, I can see the step itself also has a dark background check. So now this step is completed. Let's move on to step 2. So here is where students learn about their first kind of nebula, an emission nebula. The first panel introduces the concepts, and the next few panels are about capturing objects. So students are given examples of possible emission nebulae to capture on this observation table. These are very important. We'll come back to these. The next panel includes instructions for capturing. And after that is a data collection module where students insert their images captured with the online telescope. Now, if you've started a handful of quests with the online telescope, then you'll notice that sometimes these instructions read a little bit differently than in most quests. And that's because we often curate a specific list of objects for students to capture. For Nifty Nebulae, however, we allow any nebula to be used to capture the quest. So when you and your students first embark on this quest, if you haven't gotten an emission nebulae, you'll hit Find Image here and a page will pop up. But if you haven't captured an emission nebula yet, the page that you're going to see looks something like this. It'll say, no images, no problem. You need to go on a mission. And the platform will give you a link to go to the guide page for an emission nebula. So when your students click on this page, they're basically going to a guide. So I can show you what that guide looks like. If I click on the magnifying glass and go to emission nebula, this is where that link is going to direct your students. So the guide to emission nebula looks like this. It contains some information about the basic, ideas of what the emission nebulae are, how in ultraviolet light, which is a very important aspect of emission nebulae. But then it shows you all of the emission nebulae that are available in the Slooh 1000. So perhaps a student wants to try collecting them all. That'd be pretty neat. Now, when you click on any one of these, it brings you to that object's guide, which then the student will be able to click on the mission tab, which brings us right to the same page that we saw earlier. So students can find a mission that will be successful, and they will schedule it and get their images, complete the quest. Now, some of the quests, some of the objects that are on this this guide page, where'd the guide page go? Some of the nebulae that are on this guide page are fantastic targets. At the same time, other nebulae here would require a little work to hunt out the nebula, which is why in the quest itself, we provided some example nebulae for you and your students to capture. Now, I'm not sure if you noticed this or not, but the names of the nebulae here are actually links. And if I click on the link, it takes you directly to the mission tab for that nebula. So this is a streamlined way where you can get your students from the quest to scheduling a mission and getting themselves right back to the quest itself. So quests that require capturing objects outside of the solar system we'll have links like this throughout the quest to provide not only links to assist students to schedule missions to these objects, but we'll also give you necessary information about the seasonality in the Canary Islands, the seasonality in Chile, and midnight culmination. So these are all informations that students would use to inform them on which one of these objects could they capture to complete those quests. So I want to show you an example of why this is important. By go on the How Far quest. In this quest, students learn about the distances to objects in the solar system, the Milky Way galaxy, and deep space, which they're all at different distances because they're in different domains. And so students do a little bit of arithmetic converting from one unit to another unit. And so they need to know the distances to their objects in light years. So the observation tables are where the students are going to go to find those data to complete the quest. Okay. All right, so if a student already has an emission nebula and they were to go to this is back to Nifty Nebulae, if they were to go back to emission nebulae and hit find image, like for me, I already have a ton of emission nebula images. And so the platform tells me that an emission nebula is required, but this isn't a link anymore to the guide page. So if a student would like to capture a better image than one that they already have, they're going to have to go back to the observation table if it's one of those that they're trying to capture, or they're going to have to go to that object's mission page or guide page and to the mission tab in order for them to schedule more missions. We always encourage students to continue capturing objects so that they can get that perfect shot. Awesome. So after capturing an emission nebula, students will learn how the nebula gives off light, and then they're asked to analyze their captured image. So we did have a number of objects scheduled on the telescopes to look at tonight, and unfortunately, we're clouded out, but I still want to show you an example of an emission nebula. Probably one of the most spectacular emission nebulae that you can capture on the online telescope is the Orion Nebula. And that's what we have right here. This is one that I captured a few months ago. And this nebula is just south of the belt stars of the Great Orion Nebula. It is visible to the unaided eye. The Orion Nebula is one of the most scrutinized objects in the night sky. It's the closest star-forming region to Earth, and embedded within is a tremendous complex of gas, dust, and stellar nurseries. The Orion Nebula is a bubble of emission, and there is some reflection nebulae here encasing one of the youngest star clusters ever known, the Trapezium cluster, which is in this center region right here. This cluster of stars is only 300,000 years old, which is about the same age as our species. Now, when I look at this, I see a celestial hooded figure with outstretched arms. Now let's see, this is a view through the Chile 2 telescope, but this is what the Orion Nebula looks like through the Chile 3 or the Canary 3 telescope, which has a bigger field of view. I love this view because I love this southern loop that we can really see here. That now all of a sudden, instead of a celestial specter, now I see jaws of a celestial shark just eating up a bunch of young stars. There's been a lot of studies that shows that there's a lot of evidence of protoplanetary disks, and so there's young planets that are forming in this cluster as well. Now, the way that we can understand how this nebula is giving off light is through this model. So here, what we have is the Orion Nebula has about 3,000 stars in the cloud. The Trapezium cluster, which was in the central region, is giving off intense UV radiation that's being absorbed by the clouds that's surrounding the nebula. Now, depending on what level you teach, you would say that this cloud is ionized. But if you're in elementary or middle school level, you can just say that the hydrogen atoms in the cloud absorb this energy and they re-radiate that energy as this reddish glow that you see here. So this is called hydrogen alpha emission. So the actual gas itself is emitting light here. Pretty wild to think about. How this large chasm is carved out by the trapezium cluster's light. So this is it. The trapezium conveniently faces Earth, which allows students to peer deep into the heart of the Orion Nebula. So this is our emission nebula that we're going to use for tonight in this quest. So I'm going to go ahead and put it into the image slot. I'm going to hit find image, and I can see this beautiful shot right here. This capture of the Orion Nebula is one of my favorites through Canary 3. So let's go ahead and insert that into our step. And underneath this, so like I said, we get an explanation about why emission nebulae are red. And then we get to see that students get to analyze what it is they see through the telescopes. They put in their analysis here. Now, the next iteration of this quest, which is coming out in a couple of months, is going to include more models for the different nebula types. So here's what they look like here. So these models are going to help this quest be aligned with NGSS, and it's going to help you and your students see how these nebulae are giving off light. So the next step, where did that go? Here we go. The next step is for reflection nebula. And I hit on that, got here. So this step is formatted similarly with an introduction to the nebula type, instructions for capture, and an observation list as well, a data collection module, and then there's an assessment of what they're seeing. And then a small breakout lesson on the history of the Andromeda Nebula, which at one time was called the Andromeda Galaxy, which at one time was called the Andromeda Nebula. So the reflection nebula that we were going to see together in the telescope was called the Iris Nebula. And here is an image here of the Iris Nebula. Now, I can't quite figure out why they call this the Iris Nebula. Could these wisps of clouds be related to the color that's in our eyes? Or perhaps is this related to the iris flower? Maybe these are like petals coming out here. The word iris also refers to shades of colors from blue to violet, which we can definitely see some blues and violets here. There is also a genus of praying mantis that's called the iris. And I don't know, maybe these here are the pincers of the praying mantis coming together. It's kind of fun. But really what this is this is a cloud of gas that's behind a bright star right here. Now, this cloud of gas, the Iris Nebula, is 1,400 light years away. And if we look at the model for how a reflection nebula is formed, it looks like this. So we basically have between the nebula and Earth are some bright stars that are giving off a lot of light that are literally reflecting off of the cloud, and all of that light is directing itself to Earth. For the Iris Nebula in particular, it's this young star right here. It's called HD 200775. It's giving off the light that's reflecting off of the nebula that we see here. Now, this star is actually 200 light years closer to us than the cloud. What's remarkable is that this star is so hot that it's giving off enough UV energy to slightly ionize the cloud as well, adding a faint reddish color to our capture. So red light and blue light combines to make purple violets, which is reminiscent to the Iris name again. So maybe that's what the Iris name comes from. Fun. So now that we're on the reflection nebula step, let's go ahead and insert our Iris Nebula here. Now, after we learn about reflection nebulae, the next kind of nebula is called a dark nebula. And a dark nebula, while we wait for this to come out, a dark nebula that that we are going to investigate tonight is called the Snake Nebula. And this is a fantastic capture from the Canary 1 half-meter telescope of the Snake Nebula. And you can see it right here. It looks like somebody took an eraser and just erased a bunch of stars. But that's not actually what's going on here. This serpent-shaped cloud of matter is hiding a bunch of new stars forming within. So let's check out the model for a dark nebula. So this is the model for our reflection nebula. The dark nebula has the star and the gas trading places. So between a bunch of stars and Earth is a cloud of thick gas that's not allowing the starlight to penetrate the cloud and continue on its journey to Slooh's online telescopes. So here's our Snake Nebula through Canary 1. Here's what the Snake Nebula looks like through Canary 3. I really like this one too. You can definitely see the Snake Nebula right here. And like I mentioned earlier, it almost looks like somebody just took an eraser and erased a bunch of stars from this image. But really, this is a cloud of thick gas that's between us and the background stars here. So you can imagine this same stellar density, the same amount of stars per circle is all throughout this image. And there's literally just a thin cloud, a thick cloud of wispy gas that's hiding a bunch of infant stars growing like pearls on a string within. So this one's pretty neat. I really love these dark nebulae. You can even see some more dark features here and here and here. And these are all places where there's new stars forming. Neat. So now we can move on to the dark nebula step. And we can see that it's set up exactly the same as the others. Gives a brief on how the nebula looks. Then it gives instructions on which nebula to look for, gives some suggestions, and then we have our data collection step. Hit find image here, and we can insert our Snake Nebula that we just looked at together. And this is going to insert it into the quest. And then we'll be able to see what the next activity is afterwards, which is basically a small section on American astronomer Edward Barnard, who was really fascinated by these dark nebulae. Here's an image of him and his telescope here. Now, there's a collection of dark nebulae that a catalog that are named after him, the Barnard catalog. And so students get to learn a little bit about that history. Just like before, they analyze their dark nebulae and then continue on to the final step, the final nebula step. The final nebula that students learn about are called planetary nebulae. And the step is formatted just like before. They learn about what planetary nebulae are, and then they're given some awesome example captures for their poster. Then they have instructions, and then there's a data collection spot. And then the last little mini activity is learning a bit about how planetary nebulae, or why planetary nebulae are named that way, despite having nothing to do with planetary formation. They learn a little bit about the Herschel's connections with these as well, which I don't want to spoil the fun with that. And they get to ask questions about their image. So let's go ahead and put in the planetary nebula for our poster here. Now, the one that we were going to look at is called the Ring Nebula. And the Ring Nebula is pretty far away. It's 2,500 light years away. It's pretty small. It's only 2.5 light years across. Early observations of the Ring Nebula, this is with, can always see this here. This one was taken with Canary 2 telescope. And this is what the Ring Nebula looks like in the Canary 4 telescope. So both telescopes give slightly different appearances. So we see the ring nebula through its poles instead of the equator. Studies have shown that planetary nebulae are more hourglass shaped instead of circular shaped, although we see planetary nebulae be rather circular in shape more often than not. Now, this blue-green center surrounded by this orange ring, and almost looks like a diamond right there, is the reason why we call this one a planetary nebula. So let's take a quick peek at the model. So planetary nebula is what happens at planetary nebula is what happens at the end of a star's life. Stars like the sun. Here we go. And what happens is, as stars evolve, like the sun and lower mass, strong stellar winds start to cause the stellar layers to drift away from the star. Now, over time, once this happens, eventually the core of the star will be exposed to space and turn into what's called a hot white dwarf, or a carbon star if you're more advanced. Now, when this happens, this white dwarf is incredibly hot. The sun, for example, is 6,000 Kelvin. The white dwarf that's in the center of the ring nebula is 125,000 Kelvin, so 20 times hotter. And this is causing intense UV radiation to emanate from the core and move through the stellar layers that are drifting away. What's really cool about that is certain frequencies of that ultraviolet light are absorbed by different atoms that are in those stellar layers, causing them to glow. So the colors that you see in the telescope are related to the species of atoms that are present there. So I really like these models for the planetary nebulae, because you can see that planetary nebula is reminiscent of an emission nebula. The light that we're seeing from the ring here is not reflecting from the white dwarf, but the ring itself is emitting light, which is fascinating. Now, to complete the NGSS picture, there is a ton of UV light that actually transmits through all of these stellar layers and just makes their way through the rest of the universe, which is pretty cool to think about. This is how we can actually see planetary nebulae further away in the Milky Way and in other galaxies, because you can use ultraviolet telescopes to do that. So moving back over to the Nifty Nebula Quest, we can put in our ring nebula in for our planetary nebula. Cool. So now that we have all 4 of our nebulae in here, I can go ahead and make the poster. So when I go to the next page, in a moment, we'll be able to see the poster. So here we go. And the exploration ends. We scroll down. So here's our Nifty Nebulae poster. So this is a poster that we made tonight. We were going to capture images with the telescopes, but I had scheduled these images last weekend just in case, and I'm really glad that I did that. So this is neat. So I want to show you some other things with Quest real quick in the remaining time that we have. I want to show you on Milky Way's doppelganger what it looks like when you're embarking on a quest that has a curated set of objects where you have to capture those specific sets. So this is for an emission, the elliptical galaxy step for the Milky Way's doppelganger quest. And this quest teaches students all about the different kinds of galaxies that there are in the universe. It teaches students about how we figured out that the Milky Way was a galaxy in general, and challenges students to literally go on a hunt for the Milky Way's doppelganger. So students would schedule missions using their observation table. And again, this observation table tells them the visibility for the Canary Islands and in Chile and the midnight culmination. So everything that they need, they can get right from this page. These links go right to the mission tabs, so students have a streamlined path to get to the telescopes. When I click on edit image to potentially change an image, you'll notice that all of the available galaxies for this step are listed here, but again, they're not links to the guide pages. So you're going to have to go back and use these links that are in the observation table, the capture list, to go and schedule missions for these particular things. Great. So let's talk a little bit about how students are assessed within quests. So I mentioned earlier that a Slooh quest assesses learning in various ways, such as multiple choice questions, fill in the blank questions, analyzing captured images, and more. So the output is clear if a student answers correctly or incorrectly for non-free response questions, and inquiries that we ask support the learning of the material. So in this particular step from Myth of Virgo, I'm showing where students are learning about how big and how far away the stars that they captured in the quest are. There's a spot where they have to take everything that they've learned and they're quizzed on which of these stars is the closest, which is the furthest, which is the biggest, the smallest, closest temperature to the sun. And you can see that students are told correct, correct, or incorrect if they answered wrong. So they'll be able to go back in and change this. So I also want to show you an example of what a math quest looks like as well. So, or a math question looks like as well. And this is coming from the Rulers of the Universe quest, which teaches students about the relationship between angular size and distance. Students learn about angles, degrees, radians, and how they measure the size of the telescope's field of view. The quest also investigates globular star clusters, which are all about the same physical size. And students see what two objects of about the same size looks like at different distances through the telescope. So in this particular step, they're given the equation that relates the angular size of an object to its physical size and physical distance. And then they're given the physical size of the moon and the physical distance that the moon is from us. And they're asked to calculate the angular size of the moon rounded to the nearest arc minute. Now, the challenging part about this is that the answer to this equation is given in the units of radians and not arc minutes. So students are going to have to go on one additional step to convert their value from radians to arc minutes. And I'll show you this in a second. So if we were to just substitute the given values into the equation, it looks like this. And I love seeing the equations like this because I can see that the kilometers cancel out and we're just left with 0.00904. So again, this value is in radians and we need this value in arc minutes. Now, in principle, your students could convert it from radians to arc minutes, but we included this angular conversion calculator to help students get from one answer to the other. So when I go 0.00904 and hit convert, I get 31.07. So rounding to the nearest arc minute is 31. Now, suppose a student were to just put in 0.009. I hit convert, we get 30.9. So again, this rounds up to 31. So, and I hit edit answers and I enter my answer here, 31 arc minutes, hit submit. I can see that I get a nice correct here. Now, if a student put in the decimal, the 30.9 arc minutes and hit submit, it's going to say incorrect. They didn't follow the instructions. They need to round their answer to the nearest arc minute. Okay. Now, Canary, I want to show you how to, I want to show you what a free response question looks like as well. So in our Radiant Star quest, we have, this is where students learn all about how the sun generates light and how that light makes its way from the core of the sun to visible light that makes its way to Earth. And along the way, students learn about all these things, and then they're asked to tell us what they've learned. How does high energy light produced in the core transform into visible light that reaches Earth. They put their response here. They basically fill this whole thing out with a nice paragraph response. And what's really neat is their response really does show up right on their poster. Now, the Canary 5 Solar Telescope operates differently from the rest of the online telescope arsenal. As it turns out, the sun is already set on the Canary Islands. So I prepared this brief video to show you what a capture of the sun looks like through Slooh's Canary 5 Solar Telescope. So all you would do is you'd click this camera icon and boom, that captures an image of the sun into the student's collection. So when we click on this, you can see the image looks really cool. Awesome. So with the time that we have remaining, I want to talk a little bit about how quests are used in the classroom. So let's navigate back to the dashboard. So you may have noticed that above the quest map is this button for the quest curriculum guide. And this goes through all of the topics and subjects learned, the skills used, the types of objects captured, any alignment with the OpenStax College Astronomy textbook, the K through 12 core curricular alignments and supplementary alignments as well. Our team are actively working on surfacing further alignments to these curricula and to the English language arts literacy standards within quests. We do break down our quests into difficulties and grade levels, which can be filtered from the quest map. Educators have access to every quest, so you can assign easier quests to students that are a little bit behind. Students that are eager for a challenge can embark on more challenging college level quests, but I would urge you to check out quests that are in adjacent grade bands, as there might be a quest that'll fit your needs in the elementary school that happens to be labeled as middle school. So you may be wondering how quests have been utilized in the classroom. Some classes assign quests as homework assignments and guide student learning through a series of quests. While others require accumulating a target number of gravity points per week, allowing students to have more of a self-guided journey through the universe. Now, quests, I must add, are the easiest way to earn gravity points on Slooh. Now, like a Reese's peanut butter cup, there is no wrong way to consume a quest. As I mentioned, integrating quests as homework classroom assignments is a good idea. Colleges could use longer quests as laboratory assignments, as they are the perfect length to keep students engaged for an entire lab period. Shorter quests are ideal for college astronomy labs as a supplement or additional section to an already put together lab assignment. Quests are a perfect jumping off point for a research project or report, perhaps surrounding Project Apollo or Clyde Tombaugh or some other inspiring object or objects captured within a quest. Now, quests mainly follow astronomical concepts, but they also cover important STEM and STEM adjacent topics: mathematics, science, history, mythology, literature, anthropology, and more. So it's important to really check out this quest curriculum guide and see which quests will fit your needs. Now, suppose you want more ideas for using quests in the classroom. In that case, I suggest checking out some of our past professional development webinars put on by professional development hosts Stephanie Hanover, John Gianfort, Nicolette Letelier, and Kurt Messick. Did you know that you can find them from the Slooh menu? That's right. If we hit on these three parallel lines, you can see that there is a section that says Star Party. So when you click on that, it'll take you to our Star Party page. And when we get to the Star Party page, there'll be a little button that says professional development that's going to filter out everything but the past PD webinars. Awesome. So here we go. So here's all of the Star Parties. Hitting on professional development filters out everything, and hovering over, you can see which professional development you would like to consume. So a few more things in the last 10 minutes, and I cannot believe how fast this hour has rocketed by. I want to introduce what are called learning progressions. Learning progressions are a series of quests that surround a particular theme. These learning progressions are planned to be released by the beginning of the next school year. So keep that in mind, but I want to preview them because I want to get them on your radar, and I'm just really excited to talk about them. So the material presented in these learning progressions build upon themselves to get a more complete learning experience. So the first learning progression is the online telescope basics, which includes nifty nebulae, Milky Way's doppelganger, how big and how far. After completing this learning progression, students will have the skills necessary to command the online telescope at Slooh. They will learn about the different types of nebulae and galaxies and better understand the three domains of Slooh: solar system, Milky Way, and deep space, by investigating the sizes and distances of objects in different units. The second is explore the solar system, which includes Solar System Explorer, capture 4 giant planets in the footsteps of Clyde Tombaugh and in the footsteps of Kepler, planetary motions. Students have a complete tour of the solar system from the sun to the Kuiper belt. They learn about the latest theory of solar system formation and use the online telescope to capture nearly every planet in the solar system. They recreate Clyde Tombaugh's discovery of Pluto and even make an animation of Pluto moving out of the images students capture in the online telescope. After learning about Johannes Kepler's 3 laws of planetary motion, they discover the relationship between those laws and Isaac Newton's theory of gravitation. The third is stellar evolution, which contains stars like ours, Out with the Bang, There Goes the Sun, and Starlight Starbright. Students learn about and capture each stage of stellar evolution and explore the life and death of stars like the sun and more massive than the sun. Students construct models with their captured images and text explanation. The learning progression tops with a quest that uses the online telescope to determine why some stars appear brighter than some others, like the sun. The fourth is the Earth-Moon system, which contains the moon, lunar phases, the moon, lunar features, mystery of the changing moon, in the footsteps of Apollo astronauts, and Mauna Kea Inca moon. Students capture the lunar phases and learn the cause behind the cyclic pattern. They also learn about supermoons and eclipses. They capture lunar features and identify them. Students discover the history behind NASA's Project Apollo and capture images when the day-night line of the moon is near the 6 landing sites. Students finish by capturing more images of the moon while they learn about the Inca Empire from South America and how they viewed the moon, its importance to their culture, and uncover 3 Inca lunar myths. Awesome. I want to, in the last few minutes that I want to preview some upcoming quest-related features for my final segment. So these mainly pertain to the workspace, your classroom workspace. So I'm going to scroll all the way down to the bottom of the dashboard, because that's where the workspaces are. And I want to show you my workspace, John's Astronomy Club. So hello to all of you who are attending my professional development, both here on Zoom and on the event page. Thank you so much for joining me. What is really cool about classroom management is when you click on members, you can see where your students are at. You can see their last action. You can see the quests that they've completed, the quests in progress. And clicking on this eye lets you see actually which steps they're working on and have completed as well. You can take a peek at their quest PDF reports right here, which would let you see what answers that they've been entering and other information about the quests. Now, here's some of the new stuff. The assessment reporting within these quest PDFs are going to be more robust. We are going to let you know how many answers the students tried for those multiple choice questions. The ones that have 4 selections, we'll let you know if they took them 4 tries. And for fill in the blank questions, we'll also let you know how many attempts and what the attempts were for those fill in the blanks. Also, we're generally tightening up the reports by removing some of the excess white space. Also, the students' images that they've captured in the telescopes for the quests are going to be in here, as well as the montages too. One of my favorite features, and this will be one of my favorite features, and this will be the last feature that I'll talk about tonight, is called the teacher resources. When you navigate to the quest overview pages, very soon for some quests, you'll begin to see a button that says download teacher resource. And this is going to be a spot where we can give you all of the information necessary for you, the educator, to know everything about the quest, such as seasonality, number of images, collection time, activity used, skills used, core subjects, curricular codes, vocabulary words, and more. There's also going to be a section in these resources for what your students are expected to learn. Maybe what are some tips for success? We'll give you a preview of what your students will create, define the vocabulary words, we'll give you some detailed curricular alignments and show you where the curriculum is covered, and we'll provide an answer key for every question in the quest so that you can teach these quests to your students to the most success. Now, there will also be some additional resources as well in there if those particular quests needed. Now, I want everybody to keep a sharp eye on the professional development webinar schedule. So I'm sure we all have this PDF. Keep going back to this PDF because it is updated regularly. Old webinars old webinar links are inserted and new webinars are inserted at the bottom. So this is the best document that you can have to access these webinars. Now, don't forget that you can also check out webinars from the Slooh menu as well. You click on those parallel lines and click on Star Party. That'll get you to, and professional development, that'll get you to all of the professional developments, and it'll also show you the upcoming professional developments as well. So I am going to be doing this exact webinar again. We're probably going to cover a little more information next time. So put this in your calendar so you can check this out with me. So I want to, got a few more minutes. I want to tell everybody when our next professional development webinar is going to be. It's getting started with the online telescope Star Party with Paul Cox. This is open for all members, educators, students, everybody. And it's going to be starting at 5 p.m. Eastern, 2 p.m. Pacific, 21 UTC on Saturday, May 28th. That's right. It's just in a few days from now. So even if you want a refresher or learn about some of the new things that we have at Slooh, go ahead and join this party. We are going to have another one of these on Thursday, June 9th as well. This one's at 8 p.m., 5 p.m., and right at the stroke of midnight on June 10th UTC. So make sure to check out those. I also, one last thing, I want to let everybody know that the community-run Star Party, Tuesdays, Let's Be Done by 10 with Keith and Gresham, starts at the top of the hour on our Discord channel. So when you're done here, make sure to head on over there where they're discussing stars, space, and other astonishing things they are capturing in the online telescopes at Slooh. Thank you so much for your attention this evening, those in the webinar, and especially those watching from our event page. I hope that you've had a blast exploring the universe with your students, and I can't wait to hear your feedback. From this point on, I'd like to open up the floor for questions. Thank you so much.